Let's now consider this Venn diagram problem. The probability of event A is 0.2, probability of event B is 0.4, probability of event C is 0.5, probability of A and B is 0.12, probability of A and C is 0.14, probability of B and C is 0.23, the probability of all three is 0.08. Find the probability of all of these four events. So to begin, we'll draw the Venn diagram that's associated with this problem. So I've got a big circle for A in a different color, blue. Let me draw the circle for B. And in green, let me draw the circle for C. Okay, so I'm going to work from the smallest numbers and work outward. So A, B, and C, the chance of that happening is 0.08. Okay, and again, let me mark A here, B here, and C here. The chance of A and B happening is 0.12. I've already got 0.08 here, and so that leaves 0.04 here. So that would be the chance of A and B would be 0.08 plus 0.04, which makes 0.12. A and C is 0.14, so I need 0.06 here, so that the intersection of A and C, this region here, would be 0.14, and the intersection of B and C is 0.23, so 0.23 minus 0.08 would be 0.15. So the intersection of B and C would be 0.08 plus 0.15 or 0.23. Finally, we need to get the probability of A. So in the red circle, the total must be 0.2. So 0.2 minus 0.06 minus 0.08 minus 0.04 gives 0.02. So 0.02 is left out here. Probability of event B is supposed to be 0.4. So I need 0.4 minus 0.04 minus 0.08 minus 0.15. So that gives me 0.13 out here. And finally, event C is supposed to have probability 0.5, so 0.5 minus 0.06 minus 0.08 minus 0.15 is 0.21. Okay, so that's where we begin to start our problem. To begin, probability of A prime intersect B prime intersect C prime, that's the probability outside everything. So to do that, I need to add up all of the areas we see here, or all the probabilities we see here. So 0.02 plus 0.04 plus 0.13. Then here in the middle, 0.06 plus 0.08 plus 0.15. Then at the bottom, 0.21 gives me a total of 0.69. And so 1 minus 0.69 is 0.31. And that is the area, or the probability outside. And so the first answer is going to be 0.31. The probability of A union C, well, I can do that by brute force. I could add up 0.02 plus 0.04 plus 0.08 plus 0.06 plus 0.21 plus 0.15. So everything but the 0.13 here will be part of either A or C. So one way of doing this would be to add up 0.02 plus 0.04 plus 0.06 plus 0.08 plus 0.15 plus 0.21. That would give me the correct answer. Another way of doing this would be that the probability of A union C is equal to the probability of A plus the probability of C minus the probability of A intersects C. By definition, the probability of A was 0.2. The probability of C is 0.5. And the probability of A intersects C is 0.14, just from the statement of the problem. And so if I just simply do the arithmetic, 0.2 plus 0.5 minus 0.14 is 0.56. And I'll leave it for you to check that that's the exact same answer you get if you add up the 0.02 plus 0.04 plus 0.08 plus 0.06 plus 0.21 plus 0.15. Okay, the remaining two problems take a little bit more work. There's a probability of A given B union C. Okay, now we've seen this in class that if I take this and multiply it by the probability of B union C, that is equal to the probability of A intersect B union C. That is our multiplication rule. Probably the first and the second is the probability, well, probably the first and the second is the probability of the first times the probability of the second given the first. So to do this problem, we have that the probability of A given B union C times, okay, probability of B union C. Well, to do that, we would add up all of the entries in black here except for the 0.02, and that works out to be 0.67. I'll let you check the arithmetic on that. So that can be found by adding up all the entries here except for the 0.02. Alternatively, this can be found in very much the same way that we found the 0.56 figure up here. Finally, the A intersect B union C. Now, so it's got to be an A, and it also has to be in either B or C. So that's these three entries here in the middle. These three entries here in the middle that I'm trying to highlight. So let me just put these in, highlight these in black for now. The entries that are highlighted there are in B and C, B or C, and they're also in A. So I need to add up those three numbers. I get 0.04 plus 0.06 plus 0.08, which makes 0.18. And so dividing, we get that the probability of A given B union C will be 0.18 divided by 0.67, and that will be the probability of A given B union C. So doing the division, we get 18 divided by 67 is about 0.0267, or 0.28 or 2687. Okay, finally the last one will be obtained similarly. The probability of A union B, or B union C given A. So using the same kind of logic we had before, if I take the probability of A times the probability of B union C given A, that's equal to the probability of A intersect B union C. So the probability of the first and the second is equal to the probability of the first times the probability of the second given the first. The right-hand side we figured out earlier is 0.18. Probability of A is 0.2. And what's left is the probability of B union C given A. And dividing, we get 0.9, 8.18 divided by 0.2. Okay, so I get two different answers here, and that's to be expected. The last probability we just got is if I know I'm in A, what's the probability of being in the black region that I'm highlighting right now? If I know that I'm in A, if I know I'm in red, what's the probability of being in the black region? And that's 0.18, the black area, divided by the total, which is 0.2. The third answer here is if I know I'm in B union C, so I'm somewhere in B union C, what's the probability of being in the black area? So this is going to be the region in black divided by the probability that's being highlighted here, the red, the blue, and the green circles to combined. So I get two different answers depending on which one comes first and which one comes second.